I do want to say one thing about going last. I got to listen to every story, and we're in very different industries. And this came out very much in the whole day. We have more in common than you know. Thinking of the satellite industry to the finance to some of the other groups, we all had the same sort of common goals, the same challenges. In actual fact, I probably could have took a slide from every person there, put it together, and presented. Although you wouldn't got the Inmarsat story about that, but the values and their challenges and why we chose OpenShift and the value we're getting out of it has come along. So the plan here was the little intro. Myself, I'm Kevin. I'm actually a manager of the new Center of Excellence built around an integration and interoperability, whereby OpenShift is now a big part of that. I don't have my technical team to support me, so any questions from a technical nature might be hard-pressed to ask. I do come from a technical background, but I'm nowhere near as technical as the guys on my team. Who was Inmarsat and what we were looking for, why we chose the dedicated environment of OpenShift, what our challenges and lessons learned, and what some of our next steps in the next few years. So who here knows Inmarsat, heard of Inmarsat? Okay, great, I got a few. Do you know what we actually do? We've been in the news, but do you know what we actually do? So that's what I want to do a little bit here. This is our head office, this is our mothership, located in London, in the UK. I'm actually from a satellite office, pun intended there, St. John's, Newfoundland, Canada. And so I had a very short trip. Other people here I know came from Sydney and France and all over the place. It's amazing, the group of people that came here. So who is Inmarsat? We were actually founded back in 1979 by the International Maritime Organization, basically to enable ships to stay in contact with the shore and to call for emergency help. And we originated from the International Maritime Satellite Organization, thus Inmarsat. We've got a 37-year track record in providing connectivity to customers on the move. On YouTube, you can find a very nice, actually, video covering 34 years of our history and what we've been a part of throughout that. It was too long to show here. It actually would have took about half of my presentation. But I do have a video to show you about what we actually do, and I promise it does play into what we were trying to achieve. Today, though, we're still in the maritime, but many different sectors as well. Governments, airlines, the broadcast media, oil and gas, mining and construction, humanitarian aid agencies. Providing global coverage, typically where terrestrial telecom networks are unreliable or we simply cannot reach. So therefore, with our satellites and the constellations, we can do a global coverage. And we do that by having the range of satellites. We have several constellations up there now. They're fully optimized with a ground infrastructure network, and we partner with a lot of market-leading distribution partners. So I'm going to play a little video which will actually show you more of what we do. This is what we're into. It's about 2 minutes, but it does play into what we're trying to achieve.
22,000 miles away, in the silence of space, Inmarsat is in touch, making millions of connections every hour, keeping the audio and data flowing to every corner of the globe. Our satellites are connecting the disconnected wherever they may be, enabling communication in a fast-paced world, saving time, money, and transforming lives, making the difference every single day. We keep people in touch in many different ways, keeping those in remote places in touch with a voice from home, keeping everyone talking when other systems have failed, ensuring information keeps flowing when normality is washed away. In fact, all the services we rely on us to do their job. You can't touch our connectivity, but it touches all of us. And like never before, people expect it to keep them connected in the most unusual locations, to help them use information to discover opportunities and innovate solutions, to make sure breaking news from anywhere on Earth transmits to everywhere on Earth. Inmarsat brings expertise and education, so those with little have a chance for more. Today, connectivity intertwines through all our lives. Modern life depends on it. Inmarsat. In touch on land, sea, and air, 24/7. In touch with our customers' needs, in touch with our futures. Inmarsat, the mobile satellite company.
Well, I couldn't say any better than that. But there is a big analogy here, and this is why it really plays into into what we're trying to get across and what we're looking for. Look at the picture there, and they talked about the connections, and millions of connections every day, and communicating across the world with different systems connecting with a system. And as I was putting this together, I was thinking, you know, what were we trying to achieve? And I thought about, we are looking to do a Inmarsat for Inmarsat. So you think about that for a minute, and what we're trying to do with a business case is really get a enterprise service bus. We're about integration. So our internal systems, our back office systems need to talk to each other. Our partners that we deal with are actually hooking up their back office systems to our back office systems. So we're talking about all these connections. And now, if you think about it, where a lot of people were trying to move, we had to transform quicker. Somebody said about being fast in the space. We want to be more agile in the Devops and the CI/CD. We are actually looking at the cloud as well to help us there. And so here's another little analogy where we can see Red Hat almost like being our launch pad, with OpenShift being our satellites that are able us then to actually connect to everything that we need to connect to as well. So there's sort of the analogy. So Inmarsat, you can think 37 years, we have a lot of monolithic systems in place. We have a lot of technical debt. We need to change. We really didn't have a core integration layer that's at an enterprise level to support all those integrations of other companies that have come into the Inmarsat family. Each of those have had their own systems as well. And a significant portion of our legacy application architecture is integrated through a point-to-point model. So in the integration aspect, the point-to-point is very hard to maintain. We can't change it very easily. It's not scalable. And it's this big mesh of everything, so it's very hard to move forward. Our objective in this case was really to simplify the architecture. And so our architecture team was looking at this, and we really need to reduce those integration activities. We wanted to provide flexibility and scalability to meet the challenging business needs. You can think about all those sectors now we are in. They have their own targets they're out and getting for in aviation and maritime and enterprise. And we need to be very reactive to what they need and what their customers need in those sectors. And we also want to have that support for hosting web services and message brokers. So Inmarsat is changing not to be only now a satellite provider, but we're looking to be an enabler. We're opening our systems so other people can build their own applications on our infrastructure. And so we need these sort of web services and a strategy for that as well. So the strategy is to focus on the future. The core of that is an ESB. It's a fundamental component of that. And we need to adopt newer architectural models than we have been used to, and that's around APIs, microservice, containerization, all those things that we've heard through all the different stories here today. And with that, the hope is that we get a very more simple picture with an ESB in the middle, clean, we can change, it's scalable, it's robust. So the decision, we didn't take very lightly, and we don't take things very lightly with just our customer base. And you think about the connectivity in the places we are. If our connectivity goes down, lives are at stake. And our CEO actually just presented to us in St. John's. He was there past Friday. He made a sort of a comment, I believe it was, every day Inmarsat saves at least 5 lives, right? So it's very important that we have these things up and running. We had to do a lot of due diligence on what the core of where we want to change. And so we came up with an exhaustive list, an extensive list of 100 plus functional and non-functional. And we did a lot of research. Everyone's gone through the POCs, we had requests for proposals, and we took months, many more months than we usually take to make a decision. Some of those criteria, again, all the people that talked here today, is about flexibility and scalability. They want resilience to avoid that single point of failure. We wanted developer capabilities, so our developer tools and developers had flexibility. There was actually different deployment options, high availability infrastructure models, load balancing capabilities and some service deployment options that gave us the capability to distribute components, formation of a logical bus, management of messages, and the isolation of components. So after many months, and actually getting a third party in as well to not only evaluate the technical aspects, but actually the company's going to be providing that to us, Red Hat came up on top, and that was based on their technical, their non-technical, and the commercial analysis above all that stuff. And to do that from an integration point of view, we decided at the end of the day to go with Fuse integration services to meet our integration needs, and that was on the OpenShift dedicated platform using the Fuse integration services. So why OpenShift dedicated? Because we needed to focus on the services. What's happening is that we have many transformations going on, and they were all waiting for an integration layer. And so we needed to get up and running quickly. And so the team that we were putting together wanted to focus on those services. We need to focus on the governance, or how we're going to use OpenShift, all the different changes that were going to happen with the new, agile sort of things, CI/CD getting embedded, and all those other changes that will happen in our company. And so with OpenShift, the architecture group actually started looking at open source projects as well, and we want to make sure that they're very stable. We found that with OpenShift and Red Hat that the OpenShift components that support the new architectural models are typically available faster. So while the other vendors that we looked at and seeing some of the things in the open source market coming down through, Red Hat was making them more available quicker and be able to support those. So we didn't have to worry about checking it out and all those sort of things. Red Hat is sort of doing that for us. So we used their templates. And because the platform was open standard, there was no vendor lock-in as well for us. We're not locking into anybody in particular. There was a strong support for premise and cloud and hybrid cloud deployments, and that's, again, through the transformation, looking at cloud first, but some things we need to keep on premise, other things we might have in hybrid, and other ones we just want to move to the cloud. And it supported different deployment models for a distributed hosting model with no single point of failure. OpenShift Dedicated is what we went for. At the end of the day, we were looking at Fabric with your enterprise, the enterprise solution on-prem. And I think this is in both, but the numerous connectors are available, but we also have the ability to write our own. The OpenShift Dedicated platform is a platform based on the industry standard Docker containers, so we knew we could just develop our own things and deploy them out there as well. It fit very well with our delivery approach, again, back to the Agile, Devops, CI/CD, and the deployment model gives us the flexibility in what we use to implement each of those services, and it let us develop, test, and deploy our services independently as well. And the bottom one here is the main one that we were doing, is we wanted to focus on doing those services, went with the Red Hat dedicated platform, so we could just have them bring up our infrastructure. So with that, we still had challenges, even though we had a good supporting partner with us. There were still some challenges as we went forward. We're really new into this as well. It's been over a year when we first started. It's only been about a half a year that we've been actually developing and getting our process together and actually deploying things to the platform. And the biggest one for us right now is capacity management. We had some assumptions that stability was going to be guaranteed out of the box, just assumptions we were making. Because we had chosen Fizz, we assumed that we would use that for all our integration services, and that the footprint of our services would be greatly diminished with the container model. These were some assumptions that we made as a development team going forward. But some challenges that we got going with that was how do we properly test and tune resource configurations for optimization? We quickly got into a situation where we weren't fine-tuning those or actually configuring the containers themselves. And we were starting to see pods recycle, and we weren't sure what was going on. Team dug into that, and we did find out that pods aren't really isolated in this case, and they can impact each other if we don't constrain the physical hardware on that node. Now, what we were doing was not setting defaults. A lot of the stuff with Java, so the JVM would automatically want to go up and use at least 25%. So as we put more services on there with heavier load, we were actually, the environment itself was trying to heal itself, and that's what we found. It was actually killing things to enable something else to be healthy. So we've learned very quickly that we had to start looking at that. OpenShift helped us start to look at the microservice model. We were going down that path as well, but when we started getting these sort of issues, now we're challenged with the balancing between having a small, independent, deployable component versus that resource footprint on the platform, right? So what I mean by that is we can have a very small service that does one simple call, but the footprint can be 256 megs, whereas if we use something that's not Camel-based or Java-based, we can probably get our footprint down to a 10 megabyte from a JVM perspective. So the lesson for us has really been about setting proper resource limits in the platform is very important, and that means really within the containers. And that's actually driven back a lot more to the responsibility to our designers, our developers, and our testers to plan for the capacity and write optimized code. And we're actually finding as well that our ops people that we're actually starting to bring into the team are part of that as well. So our developers are fine-tuning their own code, setting some of those resource limitations, and then our ops people are taking those, looking at what the full capacity is on our dedicated platform to ensure that when we do deploy a new service out there, we're not going to hit max. And so we can go and then work with Red Hat to increase the nodes in the dedicated platform. So, and the other lesson is using a microservice model can decentralize a lot of decisions regarding programming languages, frameworks, and it allowed developers to experiment more. So even with all these challenges, we find that our developers can actually play with a lot more stuff. They have their own namespace in their dedicated environment, and they can just play away. Actually, in this movement, we've moved everything to the cloud. All of our desktops as a service, now we have developer machines that are totally in the cloud on Amazon. That's connecting to the OpenShift dedicated platforms. And all of our CI/CD servers, the whole works is all cloud-based. We have nothing on-prem in our integration layer, anything to support our integration layer. The other thing as well is very important that even though a lot of technology is great, it's not going to replace a well-defined and working team structure. But we are finding that OpenShift is very receptive to the Devops model, and so it's becoming very easy to get governance around that and to improve our team. The second biggest one from my perspective on the OpenShift Dedicated is around upgrades. And I heard other people say about their upgrades, and I think one said about their, it was not recipes, it was something else. They don't trust whatever. But the assumption we were making as well was the OpenShift Dedicated would just work, and upgrades would not be something we had to worry about. Red Hat plans those, they'll upgrade, and we wouldn't have to worry about that. Everything will continue working, our pods will stay running, and all those sort of things. The other challenges we have with that as well is educating others about that platform. So not everyone understands what a container-based platform is about. In a company like Inmarsat, where we do have the silos of network and a testing group and other groups and security, it became very difficult to let them understand what this new platform is. And I think it was Joe earlier said the three things about the transformation that's going on. I think there's also a cultural change within companies when you start to adopt these new technologies as well. And every group, not just the development group and architects, need to be educated. The other challenge as well, we are very risk adverse. We want to know exactly what's going on. Just planning an upgrade in a small window with the least disruption is very important to us. And our stakeholders, my customers in that, aren't happy when I go and tell them that the upgrade is going to happen sometime this week. They want to know down to the day. And we have worked with Red Hat very closely to actually get some better communications out to let us know 24 hours in advance that they're going to upgrade our platform, an hour in advance and when they start, and then when they finish as well. So we are global. We have several teams, not only my team. We do governance for some outsourced teams as well. And they work 24/7 with the time zones and everything. So they may actually be doing testing on a weekend with some heavy load and want to get some metrics of where they're doing an upgrade and the pods are restarting. It null and voids some of their testing. So we really had to plan some windows. So the lesson on that is we had to plan those upgrades like any other, like we did before in the past, and work closer with Red Hat to plan those. Thirdly, the non-functional requirements. we actually had the assumption that monitoring and logging would be out of the box as well, and I've heard from many people today they're using different open source products to do their monitoring and logging, and it's very important that we do that, and we're finding that very quickly now from our support group and our ops groups that they want those sort of capabilities. On the dedicated platform, we can log into the portal and look at one pod, but many of our services are days running for some of the programs that we have, and we want to see the health of the different pods as they work together, and it's very difficult right now in the dedicated platform for us. I'm sure we could go out and start looking at the other open source things, and that's another benefit for being here. As we all listen to the stories, now we have some ideas to go and do that. So our challenges have been getting to that centralized logging on the dedicated platform. It has come in the newest releases, but we're having some difficulty actually getting that working. Achieving a common monitoring capability to see the health and service, I just sort of explained that one. And our developers, because we really haven't formed the DevOps sort of team topology, our developers are actually performing a lot of those administrative and supporting tasks where we have everything up in the cloud and we have our workstations and they have connections into the dedicated platform. Our developers are going in and actually creating the accounts and things like that so these things can connect. So the lesson here as well for anyone who's starting new, if they're in the rooms looking at that, understand the differences between the offerings. So what is the difference between OpenShift Dedicated and what's in the OpenShift container platform, which I believe was called Enterprise before. We understood some of those. We had forgotten some of those. I mean, it's been over a year. Some of those things we knew didn't come right away with Dedicated that you could have got with the OpenShift container platform. But it's very important to understand those differences. And again, we chose the Dedicated because we did not have to want to worry about getting infrastructure in place, installing that software. We can just worry about actually developing our services. In general, we had no assumptions here. We knew the change on the team was going to be difficult. There was definitely a mind shift change to treat the environment as containers and not as enterprise application servers. There's also a mindset that we should share authentication certificates and libraries, thinking in some of our old ways of doing, rather than thinking of what really a container is and making it independent. And down to the testing of containers and environment management. Our testing group and the testing people on our teams now are coming around to some aspects and differences of what we need to do with testing. But one of our biggest challenges, because it's in the integration layers as well, is we don't always have access to upstream or downstream systems. So how do we test that as well? So the lesson here from a general sort of thing, and I mentioned this about a few minutes ago, the education awareness across all groups and not just the architectural and development team has become very important so they understand what is happening. They don't need to know the real technical details, but they need to understand some subtle differences in how we do things. So the feedback from my team, more of a technical side, is that they did have a steep learning curve. They came from a .NET sort of world. We played around with CI, CD, so they had to learn a whole new platform. They had to learn a whole new thing on the old CI/CD practices. We did have a software configuration manager on board from my old team, and we were trying to embed that, but we never really got any traction. And they all had to learn Java. None of them knew any Java. We found there was limited syntax help for creating YAML and JSON files, for creating the containers and pods. So little things like that. They're coming and saying, can I go and ask the people while I'm down there what they use? They find there's some absence of acceptable best practices guidelines for the use of OpenShift. And I think that would be helpful. The CLL documentation, we find sometimes it's not complete or sometimes the correctness of it is questionable. Maybe we're looking at old documentation, but this is just feedback from our team. Limited validation or report from a platform upgrade. So like I was alluding to, we would get an upgrade and we would be left to find what the we would validate it and had to raise support tickets. There was one case that we had an upgrade and we couldn't even log into the portal after, and we had to raise a support case of that. So we're working with Red Hat on those sort of things as well. And the support processes, that's just internal to Inmarsat. It's changing our whole support model. Of the application management to our ops groups, to even to how development works and who owns what in a DevOps sort of culture as well. We have accomplished a lot. in the 6 months, I will say, once decisions were made and we got going. We did deliver an integration platform for these other programs that were able then to actually deploy services within 2 months after that. We're keeping our development team very interested. That's very important. Myself coming from a technical background, if you're doing the same old thing for the 37 years, now it's very new, it's exciting, and there's lots of good things to come as we move forward. We have delivered reusable enterprise level microservices. So some very simple ones that just call and return specific data back to some of our network appliances. And we're also delivering feeds, and already have done so, that does services that can handle 14 plus million messages a day. And that's just out of one application, network monitoring application, and we have many more to come. We're looking at probably over 300 plus services by the end of this year, and that's just out of one program alone. So we're looking at even more than that. And a lot of these are around call data records that we move around. Our customers need these as well. So even the load and the amount of messages coming through is going to be very important to us as we go forward. Our next steps, continuing to build. Like Inmarsat, the Inmarsat for Inmarsat is continuing to build as well. And this is our latest satellite to launch, I think, within the week out of Cape Canaveral. And there are some videos online, too, of those launches, and I'm sure we'll be all in our sites watching the launch as well. So it's a pretty exciting time for Inmarsat when we actually do launch another satellite. So the OpenShift Dedicated is going to help us keep launching forward. We're going to look at better visibility, system performance, and capacity for improved planning. I've heard that from several people, and overheard some other people talking to people who look at system performance. They evaluate other container and microservice languages to see if we can get a better, smaller footprint to some of these. We don't need the full full enterprise integration patterns for some of the things we're doing. So let's just go with a smaller footprint for some of those. Looking at making the system fully fault tolerant across multiple AZs, and that's one thing we've been asking for Reddit on their OpenShift Dedicated, and bringing operational roles into the team, just so we can start looking at capacity planning and all those sort of things a little bit better within the team. Additional uses, we're going beyond integration services. We've already purchased the BPM suite, and we're starting to look at doing rules engines and deploying those as a containerized rules on the OpenShift platform, and also the non-integration type application development, which I've heard many people here today as well saying that they're already doing. So we're going beyond the integration layer. So people outside of the Center of Excellence that I'm a part of will actually be using the dedicated platform as we move forward. And that's it.
Great.
Did I do good on time?
You did perfect on time. Whoa. Thank you. That was awesome.
So we could do a quick question or two while we set up the last presentation, and then 15 minutes to beer
Non-technical now,
or
please.
less.
Yes, the next one's not
Not too technical, he says. So the question is, do you have steady load year-round, and how do you deal with spikes in load on the services that you're deploying?
Right. We have a steady cycle of loads to what we have on the platform today. So our main focus right now is in our billing transformation. And of course, as a telecom, we do bill runs. And so we do see a peak load come around the end of the month, beginning of the month. Our customers as well, if you look at their traffic, they cycle up and down throughout the week. As we bring more provisioning systems on, you'll see things, heavier load at the end of the month, and during times of special events that's on the go. So at the media, different worldwide events that are going on, you'll actually see more SIMs, mobile units being provisioned. So as we bring provisioning, interfacing into this platform, we'll start to see those sort of things as well. So there are heavy loads in the cycle, and I have a feeling as we grow more, the load will actually steadily increase and peak every now and then as we go forward. Yeah.
Will we see containers in outer space?
Who knows?
All right.
I don't write the firmware in that on the satellites, but who knows? Yeah.
Fantastic. Actually, last question.
What was your developer's experience in
They were .NET. So I came from a Java world, actually. That's my technical background. And when I joined the satellite company, I was brought in as Java. We went to .NET. So it's been a little bit of a learning curve there. There are some nuances. But in the whole containerized platform and how to think about that, it's been difficult for them.
Cool. Thank you again for a great presentation. Thanks, Rick.